Welcome friends to our next video, and in this video we are going to learn the next power on sections, like when the laptop is power on, then the different buck converters are started one after another, and in one of that the important section that is power on, that is the RAM section. The RAMs need the power. So this RAM section or the RAM power circuit is basically one a buck converter. The buck converter concept already you know. RAMs require basically three level of voltages, and of course this depend on the RAM. So here is a chart how much the voltage is required to the RAM. So if it is a DDR1 RAM, then the RAMs require 2.5 VDD voltage, and the VTT is half to the 1.25. VTT always half to the VDD. So whatever the VDD is there is a half to the half voltage is the VTT voltage. So here in this example you can see, if it is a DDR1, this is a 2.5, then 1.25 is the VTT. If DDR2 1.8 volt, then the VTT is a 0.9 volt, and if it is a DDR3 1.5 volt, then the VTT will be the 0.75 volt, and if it is a DDR3L, then the 1.35 is a VDD, then the 0.67 is a VTD. Okay, and if it's a DDR4 1.2 is a VDD, then 0.6 is a VTD. So here we can see the half is a VTD, and SPD is a common to everywhere, that is a 3.3 volt. So basically the RAM require a three level of voltage, that is a VDD, VTT and SPD, except DDR4. Now DDR4 RAMs require a four level of voltages, that is a 1.2 VDD, 0.6 VTT, 3.3 SPD and 2.5 volt reference. So this is the fourth voltage required by the RAM. So DDR4 RAM require a total four level of voltages. So here in this concept or in this circuits, we are going to learn how the VDD and VTT voltage is generated and is given to the RAM. So here is a buck converter, and here is the SIO, and here is the RAM. So first this RAM get the 3 volt from the 3 volt and 5 volt section. It's to the SPD sections. SPD is a small chips there on the RAM, which is a bias to the RAM. Means the SPD is a detect which kind of RAM it is, what is the capacity is one. It's a one kind of bias only. When CPU turn on and then the CPU start a power on self test, at that time PCH read the SPD chips, and SPD chips tell PCH that what is its capacity, like what is its storage capacity, how many chips are there, who is a manufacturer, what is the speed, everything is informed. That chip is informed to the PCH, and then the PCH accordingly reprogram to the CPU, and then the CPU start communicating with the RAM. Okay, so that SPD chips require a 3.3 voltage, and this 3.3 voltage is coming from the 3 volt and 5 volt section, and then this buck converter will be turned on, and this buck converter will be turned on by SIO, sending the sys on signal in compile motherboard. The compile motherboard, when you turn on the press the power button, and as soon as SIO got this SLP3 and SLP4 signal, then SIO generate this sys on signal. The sys on signal enable this buck converter, and then this buck converter generate this RAM voltage. If it is a DDR3L RAM, then this 1.35 voltage will be generated, and this 1.35 is a VDD to the RAM. Okay, so this RAM got the VDD. Now this chip, this RAM buck converter have the two section. One section is a buck converter and another section is a linear regulator. That means this chips generate a VDD voltage also and the VTT voltage also. That means this 1.35 is going to the VDD pin, and then the same 1.35 is going again to the chips, to the input, and then as soon as this SIO generate the next enable signal, that is SUSP. See here in this concept, SIO sending the two enable signal. One is the sys on to generate the 1.35 volt, and another is the SUSP signal to generate the VTT voltage. So as soon as SIO generate this SUSP signal to this RAM chips, then this RAM chips receive this 1.35 voltage and convert that 1.35 into 0.67 voltage, and this voltage is given to the again to the RAM. So that is called the VTD voltage. Okay, so in this way the VTD voltage will be generated. So basically the RAM requires this 3 level of voltage if it is a DDR3L RAM, and if it's a DDR4 then in that case voltage will be 1.2 volt, and then 0.6, 3.3, and the fourth voltage is 2.5, the reference voltage. So this is called the DDR RAM voltages. And then the voltage, when the voltage is stable, then this RAM buck converter generate one signal, that is called the power good signal. Okay, this power good signal going to the next section. So in this way the RAM supply generate. So the next is we'll see how 1.05 voltage will be generated. Similar to the RAM section, here is also the same. Here also the another buck converter that generate a 1.05 voltage, and this 1.05 voltage generate by this buck converter once he get the SUSP signal. SIO generate this SUSP signal enable to this buck converter, and then this buck converter generate 1.05 voltage to the PCH, and then the PCH got the power. Once this voltage gets stable, then this buck converter generate power good signal. This signal generate a power good signal. So in this way this 1.05 voltage will be generated. So friends, in this way this all the voltage should be generated one after another. So in our laptop the 3.3 voltage already generate, then the 5 voltage generate, then here is a 1.35 is generate, then 0.67 voltage generate. This both voltage is going to the RAM, and this voltage going to the CPU also. Then 1.05 voltage is generate, that is going to the PCH. Okay, and the next similar type of buck converter is there that generate a 1.8 voltage. Okay, and this voltage is going to the CPU again. So these are the different voltages are generated in the motherboard, and after all this voltage are generated, and then only the VRM section or the CPU core section will be turned on. Okay, so thank you very much for watching this video.